Hi, so we're going to start the next topic. And the next topic is a fairly straightforward one. And the title of the topic is Solids, Liquids and Gases. Okay, we're going to start with a question. You can see it's taken from an American website. Which is heavier, a pound of feathers or a pound of lead? Or you could say, which is heavier, a kilogram of feathers or a kilogram of lead or steel? I'm going to try and show you a video now. I hope you can hear the audio okay. The guy's got a very strong Scottish accent as well.
I've got a question for you. What's heavier, a kilogram of steel or a kilogram of feathers? That's right, it's a kilogram of steel, because steel is heavier than feathers. What do you mean?
They're both a kilogram.
But steel's heavier than feathers.
I know, but they're both a kilogram.
What? It doesn't prove anything. Steel's heavier than feathers.
I know, but look, they're both a kilogram, right? So they're the same.
I wouldn't want to look at the size of it. That's cheating.
No, they're the same
No,
weight.
it's a kilogram.
But steel's heavier than feathers. Paul going to tell them?
They're right. They're both a kilogram.
Oh no, you are not.
What is it you don't get?
I'm joking.
Are you alright?
I don't get it.
It's all right.
Don't worry about it.
Okay, so of course, what we're really talking about is density. Yeah, they're both a kilogram. But of course, metals for the same volume are heavier than other materials like feathers. Okay, so this is something you've come across before. So density is the measure of how much mass does 1 cubic centimetre have. So for example, you can see on the slide here, gold has a density of 19.3 grams per centimetre cube. So this means that 1 centimetre cubed of gold has a mass of 19.3 grams. Yeah, so 19.3 grams per centimetre cubed. So that is the density. Okay, well, we calculate density. Well, if you look at the unit shows us how to calculate. The density is in grams per centimetre cubed, or the mass in grams divided by the volume in centimetre cubed. Yeah, so density is mass divided by volume. Normally we use grams and centimetre cubes, so densities in grams per centimetre cubes. It is possible that you could do the mass in kilograms and the volume in metre cubed, in which case the density would have been kilograms per metre cubed. And you would of course get a different number. And of course, as usual, we can use the formula triangle here. So if you cover up mass, mass is density times volume. If you cover up volume, volume is mass divided by density, or mass over density. And of course, density is mass divided by volume. Okay, so to find the density, we need to know two things, the mass and the volume. Now, if it's a regular shape, yes, like a cuboid, like above there, if you remember from year 8 maths, to find the volume of that shape, you multiply the height by the length by the width. Okay, and if you multiply these two numbers, you get the volume. So we can measure the volume quite easily by measuring the height, the length, and the width. And of course, the mass, we can use a scale or a balance to find the mass. And then we just do density is mass divided by the volume. Okay, now if this was a normal class, I'd give you lots of regular shapes, like this here, of different materials, and I'd ask you to measure the density. But you might have done something like that lower down the school in year 8 anyway. Okay, so that's what we do if this was a normal lesson. We're not going to do that now. Okay, so that's how you define the density of a regular shape. Yeah, we find the volume, we find the mass. So what about a liquid? Of course, finding the volume is easy. We put the liquid in a measuring cylinder. You know, that's what a measuring cylinder measures, and we can see what the volume is. Now, obviously, we just can't pour the liquid onto a balance, but what we could do is just put the measuring cylinder on the balance to find the mass of the cylinder. We could then put our liquid in, find the volume, but we could also then find the mass of the liquid and the cylinder. And then if we subtract these two, so if we take the mass of the liquid in the cylinder and subtract the mass of the cylinder, we get the mass of the liquid. Okay, so we now know the mass of the liquid, we know the volume of the liquid. Now we can use our formula. Density is mass divided by volume. Now again, if this was a normal lesson, I would give you some balances and some measuring cylinders and lots of different liquids, and we would measure the density. It's useful to remember that water has a density of 1 gram per centimetre cube. Okay, and lastly, what if we have a shape that is irregular, that's hard to measure the volume? Well, there's two things we can do here. One, we could get a measuring cylinder and put some water in it, maybe halfway through, and then we could put our shape inside. Now, of course, then the level of the liquid will rise, and in fact, the difference in the volumes of liquids is the volume of the shape. Okay, so you get a measuring cylinder, put some water in, put your shape in, make sure it's fully submerged, the liquid will go up, and that difference is the volume of the shape. Obviously, we find the mass in the usual way, just stick it on a balance. So again, we can find the density, the mass divided by the volume. There's another way you can do that. It's very similar, and again, this is something you might have done before. We have a special can. It's sometimes called a density can. It's sometimes called a displacement can. It's sometimes called an Archimedes can, because he was the Greek scientist that discovered this. And basically, it has a little spout at the side. So you fill it with water, okay, till right up to the spout. You then put your object in, and of course the water comes out the spout, and then we can measure the volume of water that comes out. And the volume of water that comes out is equal to the volume of the shape. Again, we can find the mass of the shape using a balance, and then density is just mass divided by volume. Okay, and again, if we did that, we did it last. Now, just a thing about when we're measuring volumes with a measuring cylinder, you've probably noticed in the past that when you put water into a narrow tube, the top of the water is actually shaped like this. It has like a skin on it. Now, when we're measuring volumes, all measuring cylinders are designed that you read the level to the bottom of the curved bit. That curved bit, that skin, is called a meniscus. I think that is Latin for skin. So you have your eyes with this level, you look across, level with the bottom of the skin. So if you look at this diagram over here, we look level, the volume would be, in this case, about 6.6 or whatever. Yeah, you wouldn't measure it to the top of there, you'd measure it to the bottom. Okay, and again, if this was the lesson, we'd have lots of irregular shaped objects and measuring cylinders, and we'd measure the density. Okay, so let's have a look at some examples of using the formula. Okay, so this is a nice straightforward one. A block is 5 centimetres long, 3 centimetres wide, and 2 centimetres high. It has a mass of 128 grams. What is the density? Okay, well, we're using our formula up at the top there. We know density is mass divided by volume. Okay, well, we've got to find the volume first. Yeah, so when we've got a regular shaped block, it's just the length times the width times the height. 5 times 3 times 2 is 30. I put the wrong unit there. You notice a mistake? That should say centimetre cubed. I'll change that later. Then we know density is mass divided by volume. Always write the formula down. We know the mass is 128 grams. We know the volume, which is calculated as 30. That should say centimetre cubed. If you stick that in your calculator will actually say 4.266666666, and I've just rounded that up to a 7. So the density is 4.27 grams per centimetre cube. We could then go and look on the internet and find out what substances have a density of 4.27 grams per centimetre cube to discover what the substance is made of. Okay, here's another example. A block of aluminium has a density of 2.7 grams per centimetre cube. That is the density of aluminium. And a volume of 23 centimetre cubed. What is its mass? Okay, well again, if we look at our little formula here, mass is density multiplied by volume. Write the formula down. We know the density is 2.7. That is the density of aluminium. We know the volume is 23. Mass is density multiplied by volume. Our block of aluminium will have a mass of 62.1 grams. Okay, nearly there. Finally, gold has a density of 19.3 grams per centimetre cubed. Gold is a very dense metal, it's very heavy. Remember, aluminium is only 2.7. Yeah, so this is 1, 2, 3, 4, 5, 6, so maybe 8 times heavier than aluminium. Yeah? and you have 2 tons. Well, 2 tons, a ton is 1,000 kilograms, so that's 2,000 kilograms. And because there are 1,000 grams in a kilogram, that's 2 million grams. Okay, what is the volume of gold you have? So again, if we look at our formula, we cover up volume. Volume is mass divided by density. Write the formula down. Okay, well, the mass is 2 million grams. The density is 19.3 grams per centimetre cubed. 2 million divided by 19.3 is 103,627. That's about 100 litres. So if you imagine 100 litres of milk or something like that, that will be the volume that 2 tons of gold has. Okay, that's it. Okay, so well, this week, very simple. There's just that one lesson, and there's just one sheet to do, lesson 1 density sheet, and there's some calculations using those formulas, very similar to what I've just done. Okay, please answer in Word and stick it on Show My Homework before next Monday. So it's due in on Monday. Yeah, so you've got a week as normal. Okay, speak to you tomorrow.